Our next teacher has been involved in Bitcoin since 2013. He's co-founder of Bitcoin Bay, Toronto's premier Bitcoin and blockchain-focused meetup. He also leads the Bitcoin Bay tech team, working on a variety of outbound and internal blockchain apps. Passionate about education, it is my pleasure to introduce Jerry Qian.
I'd like to just get started real quick. So I noticed that this is going to be the only Bitcoin Cash talk throughout the entire conference. So if anyone outside is not prepared for this only Bitcoin Cash talk, you should definitely come in right now because it's beginning. For the people who are actually here, let me give you a brief intro just to let people just flow in, right? And just talk a little bit about Bitcoin Bay and what we've been up to. So as earlier mentioned by Angie, Bitcoin Bay, we started out as a meetup group for a lot of the new people coming into the Bitcoin blockchain space in 2014. And what we end up doing is, very much like a grassroots meetup environment where people just come to local bars in downtown Toronto. You pay for whatever you want. Sometimes people will actually buy your drinks in exchange for crypto. And a lot of people just get their answers, questions, and all that stuff asked, right? So if people are more interested in, let's say, the technical development side of things, we have tracks for that. If people are more interested in starting companies, which quite a few people just meeting at our meetups, they formed quite a few. So I'm not too sure what the hell this format is going on, but we have a few meetups coming up, but I won't talk too much about that. You can basically just check it out on meetup.com if you're ever in Toronto as well. We run them every 2 weeks, so it's not like, we're going to stop at any moment. Okay, so let's just get right into it. Bitcoin Cash app development. Again, this is the last call. I'm not going to announce this anymore. Anyone outside, please come in. Thank you. So this is going to be the brief agenda that we're going to have today. So the idea of this workshop, I really wanted to just showcase people, not just using Bitcoin Cash, just using it as reference, but a lot of it applies to the core fundamental principles of how do you make applications with any sort of blockchain. And so, we have to go with the basics like wallet management. How do you create your keys? How do you send them? All that kind of stuff. I'll be introducing something called Bitbox-SDK, which is a developer tool that helps people, make these kinds of applications for web, mobile, or any other interfaces. We'll go into the various transactions that people can make, how do you actually create them, and what kind of customizations you can have with them. So that'll be pretty cool. Op return metadata. So the last two would be, more so on the application side. This is where we'll be not only writing data onto a blockchain, but also interpreting them and then presenting them in a more user experience friendly fashion. So we'll begin with the address management. So how many people here have wallets? Just raise a hand. Okay, sorry, bad question. How many people do not have a wallet? Good, that's good to hear. So for those of you who have wallets or have downloaded wallets, you probably have seen the 12 words that you need to write down as your recovery passphrase or whatnot. And here's actually a chart where it shows you, like how on the back end it actually gets derived. So you can have anywhere up to like 12 words, all the way up to 24 words. There are some nuances, and I'll refer more to the application side of things. There are some nuances when you try to implement this, in that you gotta consider some people only have 12 words, and some people have 24 words, and it's like they can have any combination in between. So a lot of the wallets currently, they lock the users into a certain number of words. So if you try to import your wallet to another wallet, sometimes it may not work for those reasons. Again, this is easily modifiable just by changing that parameter, but something to consider. Everyone knows mnemonic. You can have different languages, of course, not just English. You can have Spanish, French, all that kind of stuff. So once you get the wallets, once you get the 12 words, you need to start deriving all of these keys. And for most wallets, they follow a protocol called BIP44, which I believe will be on the CBP test, so please refer to that. But basically, it's a derivation strategy for a lot of these wallets to follow and implement so that you can have a lot more compatibility with it. I won't go into that right now. I want to go into the next one. The BIP44 protocol is very nice in that a lot of different wallets have multi-coin functionalities and support. So let's say if you have Bitcoin, right, but you also want to hold Ethereum or Litecoin, anything like that. Basically, in the BIP44 protocol, you just need to change one value, which is the coin index right there. There's an arbitrary list at the source link below. You guys could probably find it on Google if you searched really hard. But yeah, this list is entirely arbitrary. It's kind of like first come, first serve. So if you have a new coin or something like that, just go on there, try to register with them. I think like Neo and a lot of the Chinese coins, they love the 888 or like a lot of eights. So even though there's like nothing in between, they just want their eights. So here is an example, like here's a few examples of how you actually derive your keys from this BIP44 strategy. So the M is always going to be M. I'm not too sure why. 44 represents the BIP44 standard. In Bitcoin, I understand that some of the, particularly the Lightning addresses, they use a different standard. So again, when people are making all these wallets and trying to consider the compatibility, you gotta really consider these in mind. Coin type, account. So all these kinds of stuff, it just basically helps people to just generate new addresses. And the reason why we want to do this is, back in the day, Bitcoin, it's very easy to track which addresses was sending money. And so one of the strategies was, well, why don't we just use these addresses only once? And so you have less paper trail to actually follow. Imagine if you have one address getting millions of transactions, well, it's very easy to pinpoint that person or that entity. So this is a strategy early on in the day where, we try to obfuscate or try to make this more anonymous or pseudonymous against outside observers. Wallet management. Okay, so I'm gonna shift quickly into a few demos right here. So this is something that I actually wrote up for this application. Bitcoin Bay, we're working on basically a point of sales linking up people's wallets directly to a receive-only application. And we're actually using a lot of the technologies in here, most particularly the extended public keys up top. So in all the wallet address derivation, basically the xpub, that's what you want to give out if you want to receive payments from anyone. So imagine if you're a merchant at a local bar or whatnot, if you want every single transaction to be unique to that order, you could basically just increase that index and just generate new addresses for those payments. And I believe it's also used in a lot of the different wallets just to make sure that they're not exposing the private keys when they're generating new addresses to receive funds. If anyone wants this code, come talk to me afterwards. So you're probably wondering how exactly did I create this thing? So I use a tool called Bitbox-SDK, and it's very interesting because it's very similar to Truffle in that it allows you to connect to any sort of network you want. You just have to set up that configuration. You can make your transactions, you can generate the addresses as you've seen previously, but also you can do a lot more interesting stuff like customizing transactions, like doing a lot of the mathematical checks and really just playing with the opcodes a lot. So for anyone that wants to play it out, again, it's more so on your free time. There's a lot of example codes that you can go through, and I'll walk through them in a bit too. But there's also like developer docs here for anyone to check out. Let's see. Okay, so before I get into the examples and stuff, I want to walk people through what it really looks like to be developing applications for blockchains. So it's not like you're building the application logic into the blockchain itself. What you're trying to do is build out the interpreters so that they can take the blockchain information and then present it in a more more logical sense for the end users on the front end. So even for applications like Ethereum, they follow very, very similar dynamics. Maybe instead of a transactor, they'll have like, Solidity on all these compilers and whatnot. But at the end of the day, the front end, the back end, they still need to communicate for the end user to see what's actually going on. And there's a lot of deception that can be occurring with any of these connecting arrows right here. So probably take the security audit test that Michael Perkman was bringing up. So Bitbox-SDK. So I'll walk people through a little bit what this does. But basically, it just helps developers set up their new project very, very quickly. The bare bone version just comes with this export config, which is very, very similar to the truffle.js configuration files. And I'll show people real quick on this, I believe. Yeah, can everyone see that? There we go. So Bitbox basically helps create all these stuff. And you can see at the bottom right here, there's a whole bunch of other scaffolds. So these are kind of like templates for people to just spin everything up very, very quickly. There's a bare bones stuff that I'm not going to go into. There's also React and something called WebSocket for listening to live events. I'm just going to go into the React real quick and show people what it looks like. So ignoring all of the node modules, this basically looks like create React app because it was. The only thing was they just have a lot more of the blockchain components. So you can see it's very much all React, and then there's Bitbox-SDK as a dependency. So I'm gonna get out of that real quick. Whoops. So if you try to run this, so basically the command would be bitbox new, and then put out the scaffold name. So it would be like scaffold React sample. So I'm not sure if the connection is good enough to download everything, but yeah, there you go. Boom. So that's the whole idea with the Bitbox, is just to provide developers with a very, very easy tool to interact with this. So this is, I had rendered this already. So this is actually what you will get at after you do npm start. So basically it's a web page, very, very simple web page. It gives you mnemonics. This so happens to be in Korean, and 10 addresses. You can add more addresses if you want, but again, it's just changing that index ticker. And this really just gives you a very, very basic starting point, especially if you're like in hackathons or just want to get a proof of concept out. These tools will be very, very useful for that. I think, yeah, that's fine. So I'll get back to this. So that's basically Bitbox in a nutshell. There's of course like a lot more documentation online. Yeah, that's a React scaffold right there. So yeah, please do check out the documentation if you do want to get more involved, just playing around with it if you want. They walk people through, all the transactions and all that kind of stuff. Oh, I'll probably just show people the code real quick. Just getting out of here. So yeah, variable. Sorry. We'll touch on that afterwards. My apologies. Okay, so we'll move to transactions. So transactions is really the fundamental stuff about blockchains. And in the architecture of Bitcoin, the architecture of Ethereum is a little bit different than this. They don't usually use the UTXOs for a lot of these tracking. But for Bitcoin and a lot of the other stuff, basically it tracks all of the inputs and outputs. And so you always can somewhat know like where the coins originated and like what kind of transfer path that those coins actually took. Interesting things to note is that you can have multiple outputs, like in transaction 2 right here. So you can send one to this transaction and one to this transaction. Or you could have, the reverse or a few combinations. So in transaction 6, it actually recombines those two outputs back into the inputs right here. So yeah, it just kind of gives you some rough understanding of things. If you look into any sort of like block explorers or any lower level like these command line tools, a lot of times they will actually show you something like this, where, it'll show you the transaction IDs of the actual transaction, what kind of locking script that it used, and how people unlocked it. So this is, like what you would see at a block explorer. It's just that block explorer just make the UI a lot more digestible for the end users again. This is obviously a nightmare to read, so I hope no one tries to read this. But if you do, you can kind of get a sense of how computers will have to interpret all that data. So transactions. So Bitcoin uses something called, basically it's a language called script. It's a stack-based language, and the animation that you roughly saw there is not very good, but the idea is, we want to evaluate all these things, and the items in the stack that you see over there, it comes in kind of like as an LIFO, like last in, first out. So the idea here is that all these things at the bottom need to be evaluated. And so what happens is, it looks at op equal, or it's looking at what is equal. It's looking for 2 items. The next item below is the op 3, so one item is a 3. What's the other comparator or comparison? Well, it's the op add. Op add is a functionality that takes another 2 stacks item off. And so basically you can kind of see, has anyone played with like financial calculators in the past? No? They may be too archaic, but basically the old financial calculators work exactly as how like all this stuff do. So if you want to do 1 plus 2, you would literally do 1, 2, add. The 3 and the equal would be like extra, right? So with the Bitcoin transactions, in order to make a transaction valid, that stack needs to return either a 1 or a true, which just means the same thing. If it returns 2 or 0 or anything else, then it's like, I don't know what the hell is this. Here are a few of the most commonly used transaction scripts for making transactions. The pay to public key hash is what's most commonly used because it's what all the wallets seem to implement. It's also very, very secure in that you don't have to expose any of your public keys out to anyone when you're trying to lock up your accounts. The second one you see here is actually the original, or I believe one of the original ways to make the transactions, in that the public key and, oh, I'm sorry, there's an error here. There should not be a public key here. It should only be a SIG. But the problem with this one is that the public key is already exposed. So if the encryption or the hashing function ever gets broken, then basically you already know the signatures, the private keys, just by looking at this. So by doing a hash of this, it's just like adding in another layer of encryption. Multi-sig, so basically the idea with this is you want to pick either 2 of 3 or any sort of combinations of keys and subkeys. So let's say if we set up a total party of 5 and we want 3 people to have the signing authority. A lot of corporations have this, right? With board members or directors, someone needs to sign, someone needs to authorize things. So something like this could really help out in that, it kind of just sets up not just one point of failure. So let's say signature 2, the guy or the person, the entity lost the private keys. You can still retrieve the money through, let's say, pub key 1 or sig 1. So it's a lot more like safety and just like how do you retrieve the money back. Pay to script hash, I'm sure the Lightning folks will talk a lot more about this. This is basically how Lightning gets attached to the Bitcoin network. So I won't get too much into that. But yeah, it's very, very complex. One thing I do want to point out in the check multisig, Andreas has given talks in the past about this bug. there is an extra stack item that shouldn't be popped off, or originally it was a bug. But I'll also touch on this a little bit later, not right now. I just want to keep in mind, in the past, this is a definite bug, and people have lost money setting up multi-sigs like this. Okay, so I guess I won't skip too much about that. So one of the things that Bitcoin Cash is kind of doing that's a little bit new and different than what Bitcoin Core and Lightning and even Bitcoin SV is doing is that they're implementing something called Schnorr signatures. So as you guys seen in the past, or sorry, in a few slides earlier, there was a signature element there. So that uses something else that's apparently not as efficient. But basically the gist of Schnorr is that it kind of just hides like any sort of signatures, and you can only see whether or not your portion of that is valid. If that's valid, then everything else automatically gets validated. So it really helps with a lot of the privacy aspect. Like currently right now, there's a huge market in just tracking where the coins are going. But with Schnorr signatures, everything will basically look like a pay-to-public key hash, but behind it, it could be, like complex transaction scripts, multi-sigs, even basic rudimentary smart contracts, if you want to call them that. And yeah, there's quite a few developments that hopefully in the November hard fork upgrade in Bitcoin Cash, a lot more of this code and examples will be released for people to actually start working on. This part right here, it's very, very interesting because as a lot of people know, people got into development in the blockchain mostly through smart contracts and Solidity and the Ethereum network and all that ecosystem. So this guy actually, his name is Roscoe. I forgot what his last name was, but he actually created very, very similar to Truffle and all the EVM compilers, a compiler for Bitcoin opcodes. So I believe this also, I think this should work with Bitcoin Core as well as in Bitcoin as any derivative of Bitcoin. The whole idea is that you get to write something like this, and then the compiler will just compile all the opcodes, very similar to the transaction script that you guys saw earlier, the 4 main ones. So this one right here, I believe there is a check lock time verified somewhere in there, at the bottom, where if it's greater than the time allowed, you can just take the money and that kind of stuff. I'm gonna show people real quick. So this is what the opcodes would kind of look like, even though, as you can read, it's not exactly correctly. But the whole idea is you don't want to be writing this. And you also don't want to be like looking up and cross-referencing all these opcodes and see how all those behaviors actually work out. So you just want to go to something like, which one is this? Yeah. So you want to be able to create, can someone just, PK, am I putting in the right thing? Sorry, can someone just shout out what the P2PKH dot thing is? Is it cache? Cache? Can you guys all see that? Yeah, there we go. I should have just done this earlier. So this right here is just the regular payment stuff. The interesting to note about this is if you actually look at the JSON output. Oh crap. I do apologize for this technical difficulty. So right here, this is the JSON output. Where is it? Yeah, okay. So here's the abstract, here's the ABI. So for anyone that's played with Truffle, this looks very, very similar. The bytecode does not look like anything like the P2PKH. There's a specific reason for that. Right now, all of these compiled bytecodes are actually going into a pay-to-script hash. So this is actually the redeeming script. And after you go through all that stuff, you just evaluate the redeeming script like this. So I'll show people the thesis evaluation that Roscoe was working on. Basically, where is it? Yeah. So I'll try to open up the contract. Cache. Okay. So fairly simple contract if you want to think about it that way. So 3 payment methods. Alice can just send the money out. Bob needs to do it within a certain time frame. And Carol apparently just needs to upload an image. I don't know why, it's like just an image. The idea with Carol is that it doesn't have to be an image. It could be like any sort of hash or any sort of image file, IPFS or anything like that. So again, all this, I'll show you real quick. Just basically compiles into something like this. So again, there's a lot of inefficiencies in the bytecodes. This is not optimized. It's still highly in active beta development. But it's fun to play around, and the transactions actually work. So yeah. And for anyone that wants to check it out, it's just a cache script on Google. So you could just look it up like that. All right, I got 15 minutes, which is excellent. I'm gonna blitz through a lot of this stuff because it's gonna just intro into it. Op return is basically a opcode that allows people to write data, and it effectively there's no way to actually spend money with any sort of op return transactions. So you can kind of think of it as you just want to send like hello world, or here's my IPFS address, or blah 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 blah. But somehow you want it to just last forever. So we'll go into a few applications. I don't know if Jameson's here or not. I think he should be here later on talking about the wallet development. But he did highlight this, I think, last year, in that there are quite a few uses in not just Bitcoin Cash, but Bitcoin Core as well on op return transactions. The most notable, of course, is Omni, which is USD Tether. So thank you, USD Tether, for using op return. Hopefully we'll also get an audit from you guys. Not gonna happen. A few minor differences. So Bitcoin Core, the op returns only allow 80 bytes, so 80 characters basically. Bitcoin Cash, they increased it to 220. Bitcoin SV, Fake Toshi just wanted to go, way too hardcore, so 100 kilobytes. I think they're also trying to increase it to like a meg or like a gig soon. So I don't know why you would need to write all those opcodes, but they're doing it. Very, very hardcore. Very, very hardcore. So op returns. So what does it look like? Well, this right here is hex values. So if you put that into a text converter, that's what you'll get. Don't ask me how. I don't know. So this second one right here is actually fairly more interesting. So the 612 we'll actually ignore for now, but this right here correlates to hello world. And the way you actually create all this is, again, with a Bitbox, just put it in, blah, 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 and then you have it right there. The 612, I'll go into, this is actually part of an application that people have created using op returns. It should be in the next few slides. Yada, yada, yada. I'm going to skip this for now. Okay. So what was that 612? Memo.cache. Does anyone use Twitter? Has anyone seen Twitter messages get deleted or accounts get shut down or anything like that? Okay. So this is Twitter on-chain. So watch out, Jack Dorsey. Basically, there's no censorship or anything like that unless you just overwrite the blocks. And what they do is they use the op returns and actually write out a lot of the action prefixes. So here is the hex value of, let's say you want to set your name. So with the address they actually make the transaction, you actually create an op return output that actually indicates what kind of name you want. action prefixes right here. So the 162, I believe what they did is they somehow took these 4 bytes, flipped them like in a halfway point, so the first 2 goes into the last and the last 2 go into the first, and then they converted that value into a numerical decimal number. So if you actually try to do like the create post 6D02, just put that as 026D and then do that numerical conversion, you'll get 16 whatever. I'm not sure why they did that. It's very, very confusing, but hey, it kind of works. There's a whole bunch of other examples and stuff, and all these transactions are again on the blockchain itself. So actually go to the I'll go to here. Where's the memo? So this is memo.cache, and again, it's just an interface. People are just taking the data from the blockchain. There's topics, there's like various profiles, polls, all these kinds of things. And the nice thing is that it's very much like Twitter. But you can also create your own interface. So this is the Chinese version. They basically just took the interpreter and just slapped on whatever front end they want. So yeah, again, all these stuff is very, very customizable, how you want to set it up. And yeah, if you want to only have Chinese text, you can do that too. So this is basically the backbone of how all these applications are actually like finding all the relevant posts. Of course, all the data is still on the blockchain, but it's very, very difficult and resource intensive to find all that directly on the blockchain. So what people have done, this guy in particular, is stored all the transactions, everything, onto a local MongoDB database, so that you could just carry it around, and anytime you want to just verify it, you can pinpoint it to another node and say, hey, does this exist? Yes. Okay, great. It's legit. So the beautiful thing about this is that it allows very, very fast searching and querying of specific data. So again, like there's a lot more documentations at the bottom. These slides will be available, hopefully. It should be uploaded. And so let's say, like we want to check all the stuff from this address after this block, right? So let's say, blah, blah, blah. This would be kind of like how you would set it up. There's a protocol version. And again, all these things are, highly actively in development. So don't be surprised if the documentation is out of date. Don't be surprised if we're on version 10. Shit happens, right? If you do want to lock into a specific version, you should probably download or clone it from GitHub right now and run it on your local PC. So here's the query path. Again, it's looking for this address. I believe this is the memo cache, like make a post. So any sort of post that this guy's make, limit of 20. And this is the format that you want the result to be presented in. Let me just see if I can, yeah, okay. So something like that, blah, blah, blah. Oops. Blah, blah, blah. So all these kinds of things, I'll be honest, like even when I was trying to go over the documentation, it was not playing nice. Here's the overall documents for how to make all this stuff. It's very, very in detail. Here's the block explorer, I won't skip that. If anyone wants to actually play around and put some of these samples in here, what does that say? Unfortunately, I can't read this. But yeah, they have a lot of sample codes. Sample queries. Sorry, this is app. I don't want app. So basic. And in the basic, there should be a lot of these stuff right here. So again, all these query paths, don't be surprised if some of them don't work. Try to refer to documentation. But if you actually do post it into one of these BitDB explorers. So this right here is trying to find all of the outputs with the prefix. And I probably shouldn't have run that query. Okay, never mind. Does anyone understand cubes and blocks and rhombuses? Because I don't understand this. I think there's some encoding stuff that is just encoded differently. So there should be documentation on how to decode all that stuff. But yeah, this is basically just a very, very quick and efficient way to have all of the transactions available and ready to go. And the app that actually takes advantage of this most is something called Simple Ledger Protocol. So everyone knows about, hopefully by now, that ICOs use something like ERC20s or blah, 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 just to create tokens on Ethereum. Well, these guys actually created something very, very similar. You can create, mint, send, and burn. And these are just tokens that you just snap a finger. The nice thing about this is that the transaction fees are exceedingly low. Typically, it will cost about like 0.1 cent, 0.2 cents per transaction. So you can kind of just go wild, right? You can send like 1,000, still be about that much. I kind of want to show people this stuff right here. Okay, so this is the documentation, all that kind of stuff. There's JavaScript tools, Android, iOS. And they actually took the BitDB and customized it to the SLP specifications. So a lot of the kind of like the rules in what kind of orders transactions, like obviously if you send all your coins and you make another op return transaction that says, hey, send more coins, technically it's still valid, but to these meta rules, they invalidate that. So they apply a lot more a lot of those conditions in here. And ultimately, this is a token that the Bitcoin Bay team actually created. We created this, I don't know, it's because it's fun. Just start sending out to people. And then after a few events, we actually got hooked up with the Blockchain Futures Conference in Toronto about a week or so ago. So we were giving out a lot of these tokens, probably this date right here. And this one actually was a ticket giveaway. So what we did was, we sent it out a whole bunch of tokens to people at one of our meetups, and we wanted to give away a free ticket to the conference right here. And people kind of abused the system a little bit. I somehow had the brilliant foresight of having 8 decimal points, and we only kept track of each individual transactions. So any single transaction ID. So one person actually just spammed out a whole bunch of small, very, very small transactions, and she ended up winning, not surprisingly. But yeah, there's a few tools coming out for this, in that not only can you create these kinds of like tokens, kind of like ERC20s, but you can also create NFT tokens, so kind of like CryptoKitties. The way they kind of do it, it's still in working development, but they just categorize all those as a brand that they kind of do. And the other cool thing is that you can actually give out, quote unquote dividends through these. I don't want to say dividends because I might get into security issues, but you can give out actual, cryptocurrency, bitcoins or whatnot, to all of the holders or any subset of the holders of these coins. There's an application that came out very, very recently. I didn't include it in here because I don't think the developer tools were there. But they definitely have airdropped, I think it was 0.01 Bitcoin cash into my account just because I had this token. So yeah, a lot of interesting things that people could create. And yeah, November is gonna be a fun time. A lot more of the complex stuff will be added, and hopefully we'll have more complicated smart contracts that'll just look like regular transactions. I got 2.5 minutes. Does anyone have questions? No, so at the very, very beginning, So Bitbox actually provides all those tools for you. So, so this actually would be like how you would pinpoint which node you want to use. And you can create, development environments, production environments where you go and you can even set up your own node. You can definitely set up your own node, right? It's just a lot more maintenance and work, and other people have also set it up. So again, it's just changing this URL to whatever the IP and port number and whatnot, and you should gain access to all that. I think this should work with pretty much all of the major nodes out there. So Bitcoin ABC, Bitcoin BU, there's a few other ones, but I think most of them should work. Yeah, it should be. It's kind of like, Parity and Geth, two different clients, but Truffle still works with them and stuff. Yeah. Sorry, you had a question over there? Oh, okay. Yeah, so there's the library is on GitHub. I think it's Bitbox-SDK. Yeah, there's right here. So this right here, it has all the libraries for all that, as well as the examples that you can kind of run. So address, this will have all the libraries for dealing with addresses, the HD nodes for making making the addresses, raw transactions, all that kind of stuff is all here. You kind of have to create your own. So it has the tools for you to do that, but again, like wallet management is not like one of these like protocol consensus things. Anyone can just create their own, and so that's where a lot of the incompatibilities come in. So that's a beautiful thing, right? So it actually downloads directly from the phone node. So you need a phone node to run the BitDB database. But once you have downloaded all the transactions, you just need to update it every so while, right? So it's not like you need to validate, you need to do any hashing power. And if the transactions or those entries are in that database, it's just how fast that database is, right? Like MongoDB is fairly quick. I'm sure there are faster databases out there, but once you have it in the database, it's just basically cut off from the blockchain. Anytime you want to verify it, just connect to any sort of node you want and just verify, is this piece of data on this chain that you're seeing. Okay. If anyone does have any questions, you can definitely meet me outside or at the lobby where I'll be enjoying Colorado's great greenery. Thank you.